And since we don't have that much time between talks, I'm just going to immediately kick it off with the first talk. Ashra is going to talk about a new twist on privacy-preserving contact tracing protocols. Please take it away.
Hello, everyone. Thanks for the introduction, Otto. I'm Azra Kani, a postdoc from Lund University, and now I will present our paper titled DPI, Decentralized Privacy-Preserving Asymmetric Digital Contactors. In this paper, we proposed two protocols for digital contact sockets. As we have seen during COVID-19 pandemic, digital contact tracing can significantly improve the identification of virus coefficient. And the second art protocol for digital contact tracing is called DP3T. In this protocol, our users are broadcasting ephemeral random IDs and the RTA equals, and at the same time, they are recording the broadcasted IDs from other devices and the time of receiving these IDs and the received signal set. Then, whenever a user is diagnosed with a contagious disease such as COVID-19, they can review their broadcasted pseudorandom IDs during their contagious period. They send them to the cloud. And all users download their revealed IDs at some regular intervals. They cross-check the revealed IDs against their own recorded ID list. And if they find them there, they calculate an exposure score based on the recorded information to see if they have had a high-risk contact with the device broadcasted the real IDs. Despite significant contributions of DP3T, its adoption has been limited due to different issues, including privacy issues. And it has been shown that even broadcasting pseudorandom IDs via PLE beacon can be considered as a privacy concern. Let's consider 4 colleagues who are working in close proximity. They are called A, B, C, and D. And only B is okay with broadcasting PLE beacons. So A, C, and D are conservative users who don't want to broadcast any PLE beacons. Hence, if we have an application based on DP3T, they don't have any other options except for not using the application. So we will lose the identification of any high-risk contact in this group of colleagues. And this question comes to the mind. Can participation of these conservative users who don't want to broadcast any PLE beacons in the protocol, can their participation improve the identification of high-risk contacts? We have discussed this question in our paper by proposing 2 new protocols. In this protocols allow the conservative users who don't want to broadcast any PLE beacons also participate in digital contact. The first protocol is called active-passive DP3T. In this protocol, beside active users who are broadcasting pseudorandom IDs via PLE beacons, and at the same time they are reporting the broadcasted IDs from other devices, we have passive users. Passive users, they don't broadcast any PLE beacons, but they record the broadcasted IDs from other devices. In this protocol, if an active user is diagnosed with a contagious disease such as COVID-19, they can reveal their broadcasted IDs during their contagious period. They send them to the cloud, and all users download the reveal IDs. They cross-check the reveal IDs against their recorded ID list. If they find them there, they calculate an exposure score to see if they have had a high-risk contact with the device broadcasted the reveal IDs.
Is it for laptop for them?
But there is a limitation with this protocol. In this protocol, if a passive user is diagnosed with a contagious disease, they don't notify others. As they were not broadcasting any BLE beacons, they don't reveal any IDs, and they don't reveal anything, and then we will miss the identification of any high-risk contacts with these users. To solve this problem, we have proposed another protocol which is called DP-ACT. In this protocol, passive user also reveal some IDs when they are diagnosed with a contagious disease. As they were not broadcasting any BLE beacons, they reveal the pseudo-random IDs of active users who have had high-risk contact with them. They also reveal the time of these contacts, and they also indicate these IDs are revealed by a passive user. Then all users download the reveal IDs, and as the IDs are revealed by a passive user, active user cross-check the reveal IDs against their own broadcasted IDs to see if they have had high-risk contact with the passive user. And passive users cross-check the reveal IDs against their recorded ID list. And why? Because if we have two passive users at the same place at the same time, then their recorded IDs will be the same. In other words, having some overlapping recorded IDs means that two users have been in a close proximity. We have shown that in DP-ACT protocol, it is sufficient to have one active user in each group of users who are in close proximity in order to not lose any or miss any high-risk contacts. We have evaluated our proposed protocols using two kinds of data sets. First, we have used a face-to-face data set, which is collected in a workplace during 12 days. And here you can see some results of this evaluation. High-risk case detection probability versus the percentage of passive vehicle, and high-risk case detection probability versus the percentage of users who are diagnosed with COVID-19. And you can see that our proposed protocols, DP-ACT and active passive dependability, significantly outperform the state of art. We have also used 5 real BLE datasets to evaluate our proposed protocols. Here you can see some average results of using this real BLE dataset. High-risk case detection probability versus the percentage of passive user, and high-risk case detection probability versus the percentage of users who are diagnosed with COVID-19. Again, you can see that deeply iced and the active passive debility is outperform the state of art. Hence, finally, we can conclude that allowing conservative users who don't want to broadcast any BLE beacons due to privacy concerns can significantly improve the identification of high-risk contacts. Thank you for participating in this presentation. If you have any question, I would be glad to answer.
Thank you, Asra. Move away from that thing. Any questions? Remember, please wait for the mic if you have a question.
No.
I need it back.
So my question is, if I understand correctly, the passive users, they also warn other passive users because they're broadcasting the IDs of active users, and then other passive users can see they have seen the same active users, right?
Should they notify both active and passive users?
Yeah, but if I have seen, does it also take time into this process? Because if I have seen an active user at a different time and later on this active user was notified, basically, or is that
This active user, for this passive user, reveal the IDs of active user who have had high-risk contact with them, and also reveal the time of this high-risk contact in order to monitor.
Any other questions?
Yes.
I really don't want to give him my mic.
Thank you. I was wondering, are there any gain theoretic considerations? So, if it's in my, I'm going to benefit from the system if I don't broadcast Bluetooth beacons. Is the incentive for everybody to stop broadcasting Bluetooth beacons because they feel somebody else will take up the slack for them? So, are there any things we need to do to incentivize at least some minimum number of people to continue broadcasting beacons?
First of all, you should pay attention to this, that active user don't miss end with the identification of any high-risk contacts. But passive user can miss some high-risk contact identification, because if we have only passive users in a group, we will miss the high-risk contact. So active user accept to broadcast DLE beacons in order to achieve higher accuracy for digital for the identification of high-risk contacts. And we have done a survey, and based on that, almost 7% of people were okay with broadcasting BLE beacons. It is, of course, it is a small case, and around 30% no, they had some to unsell also.
Okay, I'll take the chair's prerogative to ask a very quick question. So you try to increase privacy by not transmitting, but then when passive users upload, especially in this setting where you're in a group with one active transmitter and let's say 2 passive users, you run the risk of then revealing co-locations between these, right? Because then would...
Yeah, I should mention that in our protocol, the passive user remain completely hidden until they decide to reveal. Until they are diagnosed with COVID-19, for example, and decide to reveal their some IDs. And we should there is a research which is done in Singapore during 3 months, more than 3 months. Only 0.02% of the population were diagnosed with COVID-19 during COVID-19 pandemic. So almost 99.98% of passive user received the highest privacy, almost highest privacy, and remain completely hidden. We can say that the privacy for this user increases. However, there are some this risk of correlation attack, which is also valid for the state of art, and there are some challenging.
I'm sorry.
Interesting.
Maybe I should ask this question. We get Doug Bar offline because I want to make sure that Christoph has enough time. Let's thank the speaker again.